There is an European project which started in 2008. We have a consortium of 11 partners coming from several countries, and the major goal is to integrate remote instrumentation, lab equipment like radio telescope or electron lasers or simpler equipment like cameras or sensor networks within the existing infrastructure. Infrastructure means computing resources, visualization resources, or data repositories.
This instrument is called float. It measures temperature and salinity and pressure. And it communicates the measured data to the satellite through the antenna and then to the Earth. Floats are usually deployed from ships and they are left to drift freely with the currents. Once they are in the water, they descend to 350 meters, they stay for 4 days, they descend to 2,000 meters, and they profile up temperature salinity. When they are at the surface, they communicate with satellites sending the data. Then they go down again, and the circle starts again. This instrument measures different parameters like temperature, salinity, chlorophyll, turbidity, and oxygen, and it moves along a sawtooth path. And they are also useful to improve the forecasting models.
The information gathered by the instruments is processed and stored in supercomputing centers in different European countries. You can see the LRZ Munich and the HLRS Stuttgart, which are providing compute, storage and remote visualization resources. The stored information is used for simulation models such as weather forecast or earthquake prediction. Gliders are able to measure different parameters of the ocean. In this example, you can see the carbon in bacteria in the Mediterranean Sea remotely visualized with the DORII software.
In this way, researchers from different experimental science fields can use instruments to generate, collect, store and process data. And all these resources are enabled to communicate with one another by means of the services offered by GÉANT and the national research and education networks.
Earthquake engineering, such as other experimental sciences, strongly relies on lab tests. For example, in order to study the behavior of a building during an earthquake, to test its capability to resist a seismic event, or simply to tune a model, a very straightforward tool is represented by dynamic simulation. A scaled version of the structure, usually referred to as specimen, is put on a shaking table, moving according to a previously recorded seismic wave profile. Our goal in the DORII project is to set up a virtual and distributed lab for earthquake engineers, employing some basic instruments such as strain gauges to measure deformation, load cell to measure applied force, and an actuator to stress the specimen. In particular, all these devices are employed to create a force displacement diagram. That is, a force is applied to the specimen while reaction and deformation are recorded in order to tune a model of a concrete wall. The problem is that a concrete wall is made of a composite material. Its behavior is far from linearity. The optimization code starts from experimental data to find the best configuration of material parameter, solving a drift control problem. All instruments are controlled through the grid infrastructure, which represents also the platform storing data and performing all the computation.
IH Cantabria is currently putting a huge effort in the development of the ORUS system. The grid can be an important part for some ORUS applications, especially those requiring the usage of a big number of cameras. Beyond that, the grid enables us to run all our new algorithms against our whole database to benchmark them. This has been the first approach to integrate ORUS in the grid with the ORUS Bench application.
The Electra Laboratory is located not very far from Trieste, on the Carso near the town of Basavica. It was built to produce an exceptionally bright light, synchrotron radiation, a tool that enables researchers to detect structural details of materials otherwise invisible.
Elettra is a synchrotron radiation facility in Trieste, and DORII represents the experimental science community and its application. Synchrotron radiation facilities are designed to produce exceptionally bright light that enables discover structural details of materials, and with many applications in many fields. Electrons are accelerated in the storage ring over there, and when they deviate from their trajectory, they emit light. Light is called synchrotron radiation, and the light is conveyed through beam lengths in experimental station where the measurements are performed.
For demonstration purposes, Elettra in Trieste developed a LEGO Mindstorms robot demo which shows the usage of the DORII software.